So in the last class, we have discussed the free radical structure and bonding. Now, in this part, we will study the formation of free radical. It is the second part of our free radical. Okay. Now, free radical formation can be by 5 ways. There are 5 dimensions through which free radical can form, and we have a trick for that. The trick is HELPR. Helper is the trick. These are the 5 ways by which radical can form. H means heat. H means heat. Now, what kind of heat? Is room temperature is sufficient? What kind of heat? How much heat? Heat. Generally more than 500 degrees Celsius, or that means very high temperature. E means H for heat. E for electricity. How electricity can be produced? Through electrolysis. Or through electric arc. Electric arc means fire arc. When two very high oppositely charged voltage, they are very close together, then there are high electricity charge is flowing, then this system, this is called basically arc, electric arc. L means light. Light means actually the system, the formation process is called photolysis. That means breaking with photo, that means photon, that means light. Now P for peroxide. Peroxides are a very good radical initiator. Then R is radical initiator. You remember in last class we have written in the last part of reaction, that is AIBN. AIBN is a very good example of radical initiator, and we will study their reaction also in the later part when we will complete the reaction in the end part of this series of free radical. So AIBN is a very good. It is a basically it is a king of radical initiator. Whenever AIBN is present, the reaction, it will move the reaction, it will drive the reaction to the free radical pathway. What is the full form of AIBN? Azo, bis, isobutyl nitrite. NITRITE. Bis you can write in a small, right? Azo, bis, isobutyl nitrite. And you have a homework to Google it. What is the structure of AIBN? Homework is the structure of AIBN. Go to the Google and type there and write here itself its structure. Okay, will you Google it or I have to tell you? Okay, I am telling you, no need to Google. Basically the structure is azo, bis, isobutyl nitrite. Then one by one, with the help of these 5 type of formation, let's start the formation of different species, different free radical. First one, AIBN. First one is basically AIBN. When AIBN will present, what will happen? AIBN structure is N double bond N, C triple bond N, C triple bond N. It's a very symmetric structure. That's why I would love to write. That's why I'm telling you. Okay. Now these are actually methyl. CH3, CH3, CH3. So this is basically a radical initiator, one of the best radical initiator. Now, it's an alternative question to you. Will it show geometrical isomerism? Yes or no? It is also homework. Will it show geometrical isomerism? Now, what will happen? Simply, this bond will break in a homolytic way, and this. So here N2 will remove, right? N double bond N was there, and here is one electron from this bond. So this is basically N2 gas, because it will increase the entropy of the system, and this is the driving force. That's why AIBN is a very good radical initiator. So what will be the product? 2 CH3, CN, and CN will stabilize the free radical. How? C triple bond N. It will have a resonating structure of like this. So 2 reasons for AIBN to be a super radical initiator. One is entropy higher, another one is stabilization on that free radical. So this is the first case where radical, free radical is generated. And there are another systems also. I will be telling you total 8 systems where 8 methods by which free radical can generate. And in the question itself, when the question will come from reaction, then you will get any one of them as a starting reaction to generate radical. Second one, epoxide. R, R or AR. R means alkyl group or aryl group. O, O, R or AR. This is basically uh, this is not epoxide. I would say it is peroxide. I thought I have told epoxide. It is peroxide. Okay. So what will happen? A simple thing. This oxygen will have two lone pair with it, isn't it? Two lone pair, and this lone pair repulsion will be very high. So what will happen? This single bond will break because this very high lone pair repulsion. So R or AR O dot. So it will generate free radical in this way. These are very simple reactions, isn't it? Third one, R or AR C double bond O Cl. Acyl halide. Sorry. R not COCl. ROCl. ROCl. This type of system, when heat or light, when heat or light is given, then what will happen? Like this. Here also R or AR O dot plus Cl dot. 4. Simple halide, simple halogen. What will happen? Because delta chi is very low for homonuclear diatomic halogen molecules. And why this will break? Because this has very high repulsion, very high lone pair repulsion, isn't it? So that's why it will break in presence of heat or light. So it will give us 2x dot. Fifth one is a very important one, a very important reagent. Often it comes into the questions. It's a very popular reaction. The name of the compound is benzoyl peroxide. This group is, his name is benzoyl group, BNZOYL, benzoyl group. So this is another benzoyl group, and this is O bond O. That means wherever O bond O is, that is peroxide. This is peroxo bond. This is peroxo bond. So this is the peroxide. So it is called benzoyl peroxide. What will happen in the presence of heat of light? This bond will break. So we will be getting 2 units of C double bond O, O dot, and further what will happen? CO2 will get removed minus CO2. The C double bond O, and this phenyl dot. So now we are generating one free radical of benzene itself. Okay, so overall, how many moles of CO2 will remove? 2 mole, because it is 2 mole. So it is 2 mole. So it is 2 mole. So we have already started 5 methods. Now let's go to the next page, and here we will complete 6th process is electrolysis, and a very popular electrolysis is Kolbe electrolysis. Kolbe electrolysis. It is the process where free radical is formed. Because these things are very important. Often questions comes in such a way that in which of the following methods free radical is generated, in which of the following reactions carbocation is an intermediate, in which of the following reactions benzyne is getting formed. This type of question are sometimes asked. So tracking this name are very much important, that where in which cases free radical is getting generated. In Kolbe electrolysis, what reaction happens at anode? That is basically C double bond O minus Na plus sodium salt of an carboxylic acid. In anode, we know oxidation occurs. So oxidation means removal of electron. Removal of electron is oxidation. So what will happen when electron is removed from here? R C double bond O, O dot, and simply CO2 will remove from here, and we will be getting R dot plus CO2. This is another method for generation of free radical. 7. We have already studied peroxide type of system, H2O2. It is hydrogen peroxide. So what radical it will generate? OH dot. This it will generate. If it is R2O2, this is H2O2. If R2O2, then RO dot will be generated in the similar way. If it is PHCO3H, then what will happen? It will give pH dot. How? PHCO3H means C double bond OOH. It is also peroxo bond, so it will break. First it will break. So again pH C double bond O dot will form, and again CO2 will be removed. Then we will be getting just pH dot. So these are 7 methods, and the last method is NBS or NCS. Double bond O, N, Br. This is N bromo succinamide, NBS. If it is chloro, then NCS, N chloro succinamide. Okay. what happened? If the conditions of H, E, L, P, R, these things are there, then what will happen? Simply this will break. Why this will break? Because the nitrogen has lone pair and the bromine has 3 set of lone pair, so there is a huge repulsion. So this will break. Now one important thing, this arrow is called mechanistic arrow. Mechanistic arrow. This starts from negative charge and move towards positive charge. But the arrow what we are using here is kind of this. This arrow is called fish hook. This is kind of hook used in fishing, right? So that's why it is called fish hook arrow. Is this a mechanistic arrow? Yes, it is also a kind of mechanistic arrow. So its source will also be a radical, and destination, it can be radical or other. Destination can be any other. Okay, so here product will be Br dot, isn't it? Now what is the point for using this kind of system to generate Br dot? This is a very important use. This system, mark my word, NCS or NBS, n-bromosuccinimide or n-chlorosuccinimide, will generate Br dot in a very slow manner. Very slow manner. If a reaction is very fast, if a radical reaction is very fast, and we want to control the speed of the reaction, then if in the reaction Br dot or Cl dot is used, then we can slowly supply the Br dot or Cl dot in itself, the reaction medium, in the reaction medium itself, by using this NBS or NCS under heat or light, right? So these are basically formation of free radical. So till now we have completed 2 part. We have divided the whole chapter in 4 part. First one was structure and bonding. Second one is formation. We have completed it now. Next will be part of stability. Till then, have a nice day. Bye bye.